Hello students, today we are going to see physical properties of amines. Up till now we have completed first of all definition of amines, then classification of amines, nomenclature of amines, then after that in the last period we have seen methods of preparation of amines. Now today we are going to study physical properties of amines. Now in physical properties, first of all we have to see their state, then color, odor, melting point, boiling point, solubility. Lower aliphatic amines, now here state. Lower aliphatic amines are gases with a peculiar fishy odor. They have peculiar fishy odor. Lower aliphatic amines means up to 2 carbon atoms. Methanamine, ethanamine, they are gases. And if the number of carbon atom increases, they are from that gaseous state, they are get converted into liquid state. Therefore, they are higher members are liquid in state. Then, in case of that aromatic amines, here aniline or other aryl amines, they are colorless liquids. They are at room temperature, they are colorless liquids. But when they are exposed to the air and light, they are converted into a brown color liquid. Aniline and other aryl amines are colorless liquids, but becomes brown due to the action of air and sunlight. When they are exposed to air and sunlight, they are converted into brown colored liquids. Then third one is regarding about the state. Aliphatic amines are gases, lower aliphatic amines, and a higher or middle one are the liquids. Then aniline is aromatic amine. Aromatic amines, they are liquid at room temperature, and they are colorless liquids, but they turn into brown color due to the action of air and light. Then solubility, it is important. Lower aliphatic amines are soluble in water. As the number of carbon atom increases or as the molecular mass increases, solubility decreases. Hence, lower aliphatic amines are soluble in water, but solubility decreases as the number of carbon atom increases. Then after that, boiling points of amines. Again here, boiling points of amine gradually increases. Means lower aliphatic amines, they have less or lower high boiling point. As the number of carbon atom increases, boiling point also increases. Boiling point of amines gradually increases with molecular mass. Then, if we have compared among isomeric amines, boiling point ordering. Isomeric amines means suppose we have taken different amines, examples of primary, secondary, and tertiary amines. Suppose we have taken N-propylamine, that contains 3 carbon atoms, but that is example of primary amine. If we have taken here ethyl-methylamine, that also contains 3 carbon atoms, but that is the secondary amine. And if we have taken here trimethylamine, that also contains 3 carbon atoms. Molecular formula is same, but that contains 3 carbon atoms. Such type of the amines, we have taken suppose that type of the amines, having the isomeric amines, same number of carbon atoms, and we have compared their boiling points. Then it is found that primary amines have higher boiling point than that of secondary amines, and here, and secondary amines have higher boiling point than tertiary amines due to the comparable mass, due to the steric hindrance, because branching increases on that nitrogen atom. Here, that is steric hindrance effect increases. Therefore, primary amines, if they have same number of carbon atoms, primary, secondary and tertiary, but the primary amines they have higher boiling point than secondary, and secondary amines have higher boiling point than tertiary amines. That is important. Then order of boiling point of comparable mass. Suppose we have taken different compounds which contains two carbon atoms. Suppose we have taken from alkane ethane, then from alkane ethane, from amine ethanamine, C2H6 ethane, ethanamine, ethyl alcohol, and ethanoic acid or acetic acid. They contains two carbon atoms. Both all these are there. Four compounds contains two carbon atoms, but their functional groups are different. But if we have compared the boiling point of comparable mass of different compounds, then it is found that alkanes, there is no hydrogen bonding in alkanes because they are not polar in nature. Therefore, they have lower boiling point than amines. Again, amines have lower boiling point than that of alcohols, and alcohols have lower boiling point than that of carboxylic acids. If we have taken such of the four different compounds, then that carboxylic acid has the highest boiling point than that of alcohols. Alcohols has the greater boiling point than that of amines, and amines have the more boiling point than that of alkanes. It is regarding about the physical properties of amines. Now listen here. Such type of the question that is given in our board's book. Primary and secondary amines have higher boiling point than tertiary amines. You know that they have lower boiling point. Tertiary amines have lower boiling point than secondary and primary amines. Or primary amines RNH2, it has higher boiling point than that of secondary amines, and secondary amines have higher boiling point than that of tertiary amines. These are the RNH2, which is general formula of primary amine. It is 1 degree, it is secondary, and it is tertiary. Such type of the question that is asked in our book. Primary and secondary amines have higher boiling point than tertiary amines. Now here, in primary amines, the structure of primary amines is like this. RNH2 means there is a bond between nitrogen and hydrogen atom, and this NH bond, it is this NH bond, it is a polar bond. Because why it is polar bond? Because there is a more electronegativity difference between the electronegativity of nitrogen and hydrogen atom. Electronegativity of nitrogen is 3 and the electronegativity of that hydrogen atom is 2.1. It means that there is a 0.9. There is a difference, more electronegativity difference between this nitrogen and hydrogen. Therefore, the bond between this nitrogen and hydrogen atom is polar bond. Now, such type of the, here is, in case of these primary amines, there are 2 NH bonds. In secondary amines, there is only 1 NH bond, and in tertiary amines, there is no bond between this. The structure of tertiary amine is like this: R3N. There is no bond between that nitrogen atom and hydrogen atom. Here, that is the difference. Now, due to the such type of the NH bonds, they are present in secondary and primary amines only. Due to the polar nature of these bonds, of NH bonds, here there is a hydrogen bonding formation takes place like this. Suppose we have taken the example like this: RNH2. I have drawn the structure of primary amine like this: RNH2. Another one is RNH2. Third structure is like this: RNH2. Now, this nitrogen atom has lone pair of electron. This nitrogen atom has lone pair of electron. And again here, this nitrogen atom also has one lone pair of electron. Lone pair of electron means the pair of electron that is present on that nitrogen atom, but in normal condition that do not take part in the bonding or reaction. That is also known as unused pair of electron, or that is also known as unshared pair of electron. But due to the polar nature of this NH bond, this hydrogen now it carries partial positive charge, and here is a lone pair of electron. It is partial positive charge means there is a electron deficient nature of this hydrogen atom. Therefore, there is this nitrogen donates the pair of electron to this hydrogen atom, and there is a weak bond formation takes place between this nitrogen and hydrogen. Similarly, there is a weak bond formation, that is known as hydrogen bonding in this nitrogen and hydrogen. Again here, there is a weak bond formation takes place between this nitrogen and hydrogen atom of that another molecule. And such type of the bonds, weak bonds, are known as hydrogen bonds, or it is also known as hydrogen bonding. And such type of the bonds are known as hydrogen bonds or hydrogen bonding. And to break such hydrogen bonds, more energy is required. And due to that reason, primary and secondary amines, primary and secondary amines only they can form the such type of the hydrogen bonds. Therefore, they have higher boiling point than that of tertiary amines, because in tertiary amines there is no bond between this nitrogen and hydrogen, or there is no hydrogen atom is present on that nitrogen atom, and due to that reason the primary and secondary amines have higher boiling point than tertiary amines. Now, another question that may be asked in the examination like this: explain basic nature of amines, or why amines are basic in nature. So, step of the question that may be asked in the examination is here. Amines are weak bases. Amines are weak bases. The basic nature of amines is due to the presence of lone pair of electron on the nitrogen atom. Presence of here lone pair of electron on nitrogen atom. And according to Lewis-Asterisk concept, an atom which donates the lone pair of electron, they are always basic in nature. Now see here, there is a lone pair of electron is present on the nitrogen atom, and that lone pair of electron can be donated. Lone pair that is to be donated, it is to be donated for bond formation. And such compounds, those which can donate lone pair of electron for bond formation, that type of the compounds are known as basic in nature. Therefore, here all these amines, they contain, suppose the structure is like this: N lone pair of electron, these three bonds, they will be attached to the three hydrogen atoms or three alkyl groups, or an alkyl groups or hydrogen atoms. They contain now such type of the lone pair of electron, and this lone pair of electron, it is donated for the bond formation, and compounds in which, or an nitrogen atom, or the compounds in which nitrogen atom donates the lone pair of electrons for the bond formation, that type of the compounds are known as amines. And here in this case, this nitrogen atom, it donates the pair of electron for the bond formation. Therefore, amines are basic in nature. Now, they can donate the pair of electron to the electron deficient species like this. Suppose we can take the example like this: R3N, it is a tertiary amine, and if it is treated with the compound electron deficient compound like BF3, this lone pair of electron, it is to be donated to this boron atom, and we use the structure like this. It is tertiary amine. R3N. Here is the bond between nitrogen and boron. It carries this nitrogen atom. It has given the pair of electrons, therefore it carries positive charge. This boron carries negative charge, and such type of the complex structure formation takes place. Such type of the structure formation takes place. Therefore, here in this structure, this nitrogen atom, it has donated the pair of electron to this boron atom, and we get the structure like this. Therefore, amines are basic in nature. Now there is one more question that is given in our book, that is, write a balanced equation for the action of dilute H2SO4 on diethylamine. Now, before this we have stated that amines are basic in nature, and there is one characteristic feature of the bases, all bases, is that they always react with the acids. That is a reaction between acid and base, that is a neutralization reaction. Here the question is like this: write the balanced equation for the action of dilute H2SO4 on diethylamine. Now diethylamine, it is a base, H2SO4 it is acid. Therefore this diethylamine, it reacts with diethylamine means C2H5 NH C2H5. It is ethyl ethanamine, or it is diethylamine. Now this diethylamine, it reacts with H2SO4. Now here, see now, here is a total of electron is present on this nitrogen atom, and it is nitrogen atom. This nitrogen atom is donating the lone pair of electron to this hydrogen atom. Now this molecule, it breaks and it gives SO4 minus and 2 ions of the H plus, like this, H plus. Therefore now here this nitrogen atom will donate the lone pair of electron to this hydrogen atom, but here there are 2 proton atoms, there are H plus 2 H plus ions. Therefore here 2 molecules of this diethylamine will be required here. Now one molecule that donates the lone pair of electron to this hydrogen atom, another donates the lone pair of electron to another hydrogen atom, and it forms the structure like this. Here now C2H5 NH. Here now H, it combines, it donates the pair of electron to this hydrogen atom, therefore it is get converted into NH2, and here such type of, there is a formation of such 2 molecules formation takes place here, NH2 and here is now this nitrogen atom, it has donated the pair of electron, therefore it carries positive charge here. Positive charge, actually these are such type of there are formation of 2 molecules, therefore it carries the positive charge, and here it is a complex like this, and this SO4 we have written SO4 like this, it is SO4 minus, and it is diethyl ammonium sulfate. The name of this compound is, it is diethyl ammonium sulfate. In this way, it is diethyl ammonium sulfate. We have to clear these positive and negative charges are balanced. There are 2 negative charges, though here is only one positive charge, but here we have taken here 2 molecules. Therefore, there are also 2 positive charges also here. Therefore, in this way, diethylamine reacts with H2SO4 and gives diethyl ammonium sulfate. Okay, today stop here. Thank you.